So we're going to find the center of mass of a person sitting in pike position with their hands over their head. We're going to use this chart to do that, and this chart shows the parts of the body broken down by several things. One is percentage mass. So like the head is 6.9% of the total mass of the person. The upper legs, the thighs are 21.5% of the total mass of the person. It also gives locations of the centers of mass of the different body parts. So the head, the upper arm, lower arm, hand, the trunk and torso, the trunk and neck, the thighs, the lower legs, and the feet. And also the joints, ankle, knee, hip, shoulder, elbow, wrist, and neck. So it gives you the percentage of the height of the person from the floor. So we're going to use this in a center of mass equation to put this all together. So let's do the x direction first. And we're going to have our center of mass equation. So center of mass is going to be given by the mass times the position. So let's do our thighs first. So the upper legs are 21.5% of the total mass. So that's going to be my mass. And I'm just going to pretend that I have a 100-kilogram person. So I'm just going to use 21.5 kilograms as the mass. Then the position, I'm also going to just calculate as a percentage. So I need to know how far I'm measuring the center of mass from the hip. So the hip is my 0 point. So I need to know how far the hip is from the center of mass of the thighs. So when I look at this chart, I'm going to look at the hip joint a lot. And I'm going to take the difference in the position of the hip joint and the position of the lower legs. I keep saying lower legs, the thighs, the upper legs. So if you take 52.1 and you subtract 42.5, you get 9.6. So I'm going to put 9.6 right here. And that's a percentage of the total height. So my final answer will be a percentage of the total height, and then we'll multiply it at the end. You could multiply each one of these percentages of the total height by 1.7. It's just a lot more calculation if you do it that way. I'm just doing it at the end. So those are the thighs. Now let's do the lower leg. So the lower legs make up 9.6% of our total mass. And then the position of the lower legs is going to be 52.1, and then you subtract the 9.6. So what you're doing there is this is 52.1 all the way to the ground. You're subtracting this piece right here, the 9.6, and that gives you this part, which is what's left, and that's what you want. So 52.1 minus 9.6 gives us 33 point. I have 33.9 written down, but that doesn't make sense. And let's see here. Let me just make sure that I did that right. Oh, because I'm supposed to be subtracting 18.2 and not 9.6. I looked at the wrong column. So 52.1, I subtract 18.2, and that gives me 33.9. So I'm going to do 33.9, and these are my lower legs. And then I do the feet. So I look at the mass of the feet, which is 3.4%. And then I'm going to do the position. So I'm going to take the hip, 52.1, and subtract 1.8, which is the feet. And that gives me 50.3. And this is the feet. Now I'm going to divide the whole thing by 100 because that's the total mass of the person. I just assumed that I had a 100-kilogram person so that I could do that easily. So then our x center of mass, you should get 7.03, and that is percent of the total height. So So now to find the total height, we have to do 0.073, sorry, 03 times the height of the person, 1.7 meters, and that should give us 0.12 meters as the x position of the center of mass. All right, now let's do the y. The y is a little bit trickier. So for the y direction, we're going to start off with just the easy ones. So we're going to do the trunk and neck. So we're looking at this distance right here to the center of mass of the trunk and neck. We look at our chart, and the trunk and neck is 46.1%. So that's going to be our mass value. That didn't come out quite like I wanted it to, so 46.1. And then we're going to multiply it by the location of that. And so we're going to take, this time we're going to do the trunk and neck, which is 71.1, and we're going to subtract the 52.1 so that we get this length right here. And that is 19. So multiply by 19 here. And then that's the trunk and the neck. Then we're going to add the head. So our head's mass is 66.9. And then the location of the head, we will take the 93.5, subtract the 52.1, and that gives us the position of the head. So that's 41.4. And now we have the upper arms. And this is where it gets a little bit tricky, because on this diagram, you can see that this is for arms hanging vertically. So they're hanging down vertically. And since they're hanging down vertically, the numbers aren't what we want, because our person has their hands up over their head. So here's how we're going to do it. We're going to find the distance between the shoulders and the hips. So the shoulder minus the hips is, let's see, shoulder is 81.2. We're going to subtract the hip, which is 52.1, and that's going to give us 29.1. Okay, so we know the shoulder to the hip. Now we're going to do the shoulder to the different parts of the arm, and that's going to, and then we're going to add them to shoulder to the hip, because what this is saying, like, let's do the hand, well, let's do the upper arm first. So this is saying if this arm is hanging straight down, the center of mass of the upper arm is at 71.7. So that's when it's hanging down, but we want it to be up here. So if we find the difference between the shoulder and the center of mass of the upper arm, then we can add that to the hip to the shoulder, and that will give us the total length. So let's do shoulder minus, I'm going to put UA for upper arm, and so that gives me 81.2 minus the upper arm, which is 71.7, and that gives me 9.5. So then my total value there would be, I would add those two together, and so I get 38.6. So I would add the 29.1, and I get 38.6. So that's what goes here. That's my position above the hip. Oops, I forgot my mass. My mass is 6.6. And then my position is 38.6. That's for the upper arm. All right, now let's do lower arm. Let's get the mass first. So our mass of the lower arm is 4.2. And then we multiply the position. So the position is, let's use a different color here. So now we're looking at the shoulder to the lower arm. We use LA for lower arm. So you have 81.2. We're subtracting 55.3. And that's going to give us 25.9. And then I'm going to add 25.9 to 29.1. And that gives me 55. So in this equation, I put 55 right here. And that is my lower arm. Okay, then we have the hand. So our mass of our hands is 1.7%. And then the position of the hand, I can do that in green, I guess. So we have the shoulder to the hand is what we're looking for there. So shoulder to hand, we're going to do 81.2. We're going to subtract the hand, which is 43.1, and that gives us 38.1. And we're going to add 29.1, and that gives us 67.2. So then here we do 67.2, and that's the hand. Then we divide by the total mass of the whole body, which is 100. And we're not putting the legs in this one because the Y position of all the legs is just 0. All right, so our Y center of mass comes out to be 17.6% of our height. So to find the Y center of mass, we're going to take 0.176. We're going to multiply it by the 1.7 meters, and that gives us 0.30 meters as the Y component of the center of mass. Wasn't that so fun?